Hi there. In this video, we're going to take a look at some data. We're going to look at how to analyze it in order to answer a question. In this lab, we had two questions, really. The first question was, we had multiple resistors. We set the resistors in series and in parallel, and we recorded what the voltage and current was of all those resistor combinations. The question we want to ask is, first, what is the value of the resistor? We use the same value of resistor over and over again. And second, we want to figure out what is, do the rules for multiple resistors, do they work? Now, in this case, I want to look at the rules for multiple resistors and figure out what I need to do to solve and determine whether these things work. So, for example, we start with a series circuit. In a series circuit, the rule is that the total resistance equals R1 plus R2 plus R3 and so on. Now, if these resistors are the same, we can simplify that by saying the total resistance equals R multiplied by N. Now, what this equation means is if I take the value of one resistor and I multiply it by the number of resistors in series, I will get the total resistance. Now, if you look at our data over here, we do have number of resistors, we have voltages and currents. What I want to do is I want to make a graph that's going to allow me to verify that, one, this rule is correct, and two, what the value of the resistor is. Now, if I look at this equation I have set up here, I can say that the R total, that can be my Y value. Certainly that is a dependent variable. I did not solve for that. The other R value is the value of the resistor. We'll call that our M, or slope. The N can be our X. And of course, we have a plus B. This equation fits our straight line linear fit equation. And if I make a graph with the total resistance on the y-axis and the number of resistors on the x-axis, the total of one resistor should be the slope. So that's what I want to try to do in this case. So what I'll do is I'm going to first take all this parallel stuff and I'm going to move it out of the way for now. We'll deal with parallel later. Now, if I look at my data, I have the number of resistors. This is on my x-axis, but I don't have the total resistance. So let me just make a column for resistance. And this is in ohms. I could be fancy and find the symbol or just put that. Now, of course, the equation for resistance, we know that is voltage divided by current. One thing I hope you noticed is that current is in milliamps. That is, a thousandth of an amp. So what I'm going to do is I'll take, first I'll tell you what, I'll go ahead and I'll just solve for current in amps. And then we'll do resistance in ohms. And so current in amps, I simply take this value and I divide by 1,000. All right. And if I drag this down, I get very small numbers, but that's okay because if I format my cells, I have a feeling that we're going to find, actually, there they are. We're going to find that if I add some decimal places, we're going to see what's going on here. I think 4 or 5 decimal places is fine. It really doesn't matter. Okay, that looks pretty good. So now I have my current, I have my voltage. To find the resistance, I'm simply going to divide voltage divided by current. And go down here. Now, one shortcut is there's a button for the decimal point up here. I can shorten up that decimal point. It looks good right there. So I've got some data. I've got I've got resistance over here. This is my y-axis. I've got my number of resistors over here. That is my x-axis. So let's go ahead and make a chart. I'm going to insert a, let's do a, I can remember how to do this on the Mac. Chart, I want to scatter. Always wanted just a scatter with plain dots. Nothing special. This may look a little different on your version of Excel, but that's okay. I'm going to select my data, and I'm going to select my, let's add a series. A series is a set of points. My x value, of course, is, if I look at my equation, my x value is the number of resistors, so we can select that easily. And then my y value is the total resistance. Select that. And I hit OK. And we see that the dots seem to line up pretty well. If I right-click on here and I can add a trend line, and this trend line pops up a window here where I can set it as a linear trend line. I can even display the equation on the chart. Okay, so we put that in there, and we can see it looks like the slope is 150, and the y-intercept is about 0. And that tells me that the one resistor is about 150 ohms, and that since the slope equals 0, I think this equation does look pretty good. I would add axes labels to this, of course. I'd add a title, but we're just going to go ahead and move on for now. Now, for the parallel circuit, it's much the same thing, and I'm going to find we're going to find the current, just like I did before. This is all processed data. Current in amps is it's that divided by 1,000. And we'll just drag this down. If you double click, it'll figure out where to go. And that all looks pretty good. And then I'll find the total resistance in ohms. Again, double click on the side here, and that will resize things for you. Resistance is voltage divided by current. And knock that down. Let's get rid of some of these decimal points here because they look a little messy. And I can do the same thing I did with the resistors in series. Now, in parallel, we know the equation in parallel is, for parallel, the equation is 1 over the total resistance equals 1 over resistor 1 plus 1 over resistor 2. This is not something that fits nicely into a straight line equation. In fact, I could say 1 over the total resistance equals N over R, where N, of course, is the number of resistors. R is the resistance of one resistor, which we know should be about 150. Now, obviously, this does not fit nicely into y equals mx plus b formula. So I'm going to do a couple things. First, I'm going to, we'll go to a new slide here. We write it up here, 1 over r total equals n over r. I want to get that total resistance out of the denominator, so I'm going to raise both sides to the -1. And what that'll do is I'll say the total resistance, the total resistance, go away, well, whatever, equals, R divided by N. And I can further say the total resistance is equal to R to the N minus 1. So now I have Y equals MX plus B, where B is 0. So what I'll have to do here is I'll have to say my slope is, to find this total resistance of one resistor, it's my slope. The X value is going to be N to the -1, and the total resistance is Y. Now, first, I'm just going to go ahead. I'm just going to make the basic graph like I did before. Make a graph. Again, I want to label all this, but due to time, I'm not going to worry about that. My X values will have, just as before, the number of resistors. And the Y values, way here somewhere, is the resistance. And I get a graph that looks something like this. Well, never mind. Whatever. Add a series, X values, number of resistors. This is thrilling, I'm sure. Y values is total resistance. And hit OK. And obviously that is not a straight line graph, and I wouldn't expect it to be. This shows me that as the total number of resistors goes up in parallel, the overall resistance goes down. So I want to look at my equation I have here, and I think I want to look at graphing n to the -1 power on the x-axis. So to do that, I'm just going to do number raised to the -1. Of course, there's no units when dealing with numbers. That makes it easy. So I'll just simply click on the number and raise it to the -1 power. Drag that down. Okay, it looks a little messy, but we can fix that with my, there we go. Let's just do something like that. And let's just make another graph. I'm going to insert a chart, a scatter plot, Oh my, this is why you don't select. That's why you don't make a scatter plot while you have something selected. It tries to do all that. Well, let's remove all those series. Ooh, gross. Okay, let's add a series. On the x-axis, now I want the number of resistors raised to the -1 power, and now I want total resistance for the y. When I do that, I should get a straight line through the origin, and oh, looks like we do. Now, according to my equation, the slope of this should be the total resistance, which we had as 150 before. Let's see what happens. We have a linear. Let's show the equation. And wouldn't you know it? Look at that, right about 150. These graphs are going to be used in my conclusion. When I can talk about, first, I look at these graphs, I can tell the resistance of the resistors looks like it's about 150, which is what it was. The resistors were 150 ohm resistors. And I can tell that my equations match reality. The type of graph that I would expect with my equation matches what I actually got. And we'll get to that when we talk about the conclusion in the next video. Hope you were able to sit through all this and understand. Thank you.